Chemistry 2, which is titled Ratios of Similarity. And we're going to answer the question, how does the area change? All right, question 64 is titled Team Photo, and it says Alice has a 4-inch by 5-inch photo of your school's championship girls ice hockey team, the one we made the banner for yesterday. To celebrate their recent victory, your principal wants Alice to enlarge her photo for a display case near the main office. When Alice goes to the local print shop, she has many choices of sizes. 7 by 9 inches, 8 by 10 inches, and 12 by 16 inches. She is afraid that if she picks the wrong size, part of the photo will be cut off, right? Because if you're having a team photo, you've got some people all the way across. You don't want to cut off someone over here or the coach over here, right? So you want to make sure it's going to be proportioned out correctly, or part of that photo will be chopped off. So which size should Alice pick and why? Okay, so what you want to do is you want to take the size of the original photo, which is a 4 by 5, and you want to see which one it is equal to. Is it equal to the 7 by 9? Is it equal to the 8 by 10? Is it equal to the 12 by 16? So you're going to see which of those is the best one. There's nothing that you can multiply 4, bless you. There's nothing that you can multiply 4 by to get 7 that you would also multiply 5 by to get 9. So that one's not equal, right? And if you tried to do the cross product, 4 times 9 is 36, and 5 times 7 is 35. And 35 does not equal 36, okay? If you set the 4 by 5 photo equal to 8 by 10, you're going to have a little bit better luck, right? If you do the cross product, 4 times 10 is 40. 5 times 8 is also 40, okay? So if you pick that one, nobody's going to get cut off. Again, if you try this one, 5 times 12 is 60, and 4 times 60 would be, what would that be, 40 and 24? 64, okay? So that one is not equal either, okay? So this one would be a bad pick, and this one would be a bad pick. Somebody's going to get cut out of the photo and get chopped off. You don't want anybody chopped off. All right, part B says the cost to print Alice's 4 by 5-inch photo is 45 cents. Assuming that the cost per square inch of the photo is constant, how much should it cost to print the enlarged photo? Explain how you found your answer, okay? So if the original photo is 4 inches by 5 inches, you multiply those, that's going to get you 20 square inches. The larger photo is an 8 by 10, so you would multiply 8 times 10 to get 80. That is 4 times the size. How do I know it's 4 times the size? Because I took 80, divided it by 20, which means it's 4 times the size. So 4 times the size at 45 cents, punch it in the calculator, you should get $1.80. All right, so the larger photo is going to cost $1.80. All right, part C says, unbeknownst to her, the vice principal also orders an enlargement of Alice's photo. However, his enlargement of the photo costs $7.20. If the cost per square inch is still constant, what are the dimensions of the photo? Okay, so you're going to take the $7.20 that the vice principal paid, divide it by 45 cents per square inch. That means it's 16 times the size of the original photo. So we're going to take the square root of 16, which is 4, and we're going to multiply the original photo by 4 over 4. 4 times 4 is 16. 5 times 4 is 20. That means that super large photo is 16 inches by 20 inches. So they're going to have a nice big one to put at the front of the school for everybody to see how amazing their ice hockey team is, right? Okay. Any questions on problem 64? All right. Down at the bottom is question 65. Question 65 says, so far you have discovered and used the relationship between the areas and corresponding side lengths of similar figures. But how are the perimeters of similar figures related? Analyze the pairs of similar shapes below for each pair, calculate the areas and perimeters, and complete a table like the one shown below. To help see patterns, write your fractions in lowest term. Underline the words lowest terms. Okay, so whatever your fraction is, you need to reduce it. Or calculate the corresponding decimal values. Okay, so the first one we're going to look at is obviously a rectangle. So you need two pieces of information for each. So first, you need the perimeter of the rectangle. To get the perimeter of a rectangle, you add all four sides. You can add 6 plus 15 plus 6 plus 15, which means that the perimeter of the small rectangle is 42. To get the area of a rectangle, you multiply 6 times 15. So 6 times 15 is 90. Then you're going to do the perimeter and area of the larger rectangle. Perimeter, you add all four sides. So we're multiplying, obviously, by 5, so that's going to be 30. Okay, so it's going to be, by 3. No. 10. Okay, so 10 plus 25 plus 10 plus 25. So the perimeter is going to be 70. And then if you multiply 25 times 10, you're going to get 250. All right, so in the first box, they want the ratio of the sides. So the ratio of the sides is 6 to 15. So why did I write 3 to 5? Yeah, we have to reduce it, right? If it's 6 over 15, they're both divisible by, oh, sorry. It's the small figure to the large figure. Okay, so 15 to 25, they're both divisible by 5, so 15 divided by 5 is 3, and 25 divided by 5 is 5, okay? Then we need to get the ratio of their perimeters. So the perimeter of the smaller figure, of the smaller rectangle is 42, and the perimeter of the larger rectangle is 70, and I need to reduce that. What are they both divisible by? I can't do that in my head right now. Let's see. 14. Okay, so if you take 42 and divide it by 14, you get 3. If you take 70 and divide it by 14, you get 5. All right, then we need the ratio of the areas. So the area of the smaller rectangle is 90, and the area of the larger rectangle is 250. This one's easy. I can do this one in my head. All right, they're both divisible by 10. So 90 divided by 10 is 9, and 250 divided by 10 is 250, or 25. Any questions on the rectangle? All right, now let's do the triangle. All right, the larger triangle is a 30, 60, 90 triangle. So I determined the sides by using the ratios of a 30, 60, 90, where you double the short side to get the hypotenuse, and you multiply the short side by 6 rad 3 to get the longer leg. Okay. Same thing with the smaller rectangle. If the hypotenuse is 4, you're going to take half of it to get the short side, which is 2, and then the short side times rad 3 gets you the longer leg. To get the perimeter, you add up all 3 sides. So 6 plus 12 plus 6 rad 3 is 28.4. That's the larger So for the perimeter, we write it right here. For the smaller triangle, we're going to add 2 plus 4 plus 2 rad 3, and we get 9.5 for the perimeter. Just so happens that reduces to 1/3. So it should have the same ratio for the sides as it does for the ratio of the perimeters. These two numbers are the same. These two numbers are the same. Okay? Now we need the areas. So to find the area of a triangle, you multiply base times height and divide by 2. So on the larger triangle, you would go 6 times 6 rad 3, divide by 2, you get 18 rad 3. For the smaller triangle, you'd multiply 2 times 2 rad 3 and divide by 2, and you get 2 rad 3. So the ratio of the areas is 2 rad 3 for the smaller, 18 rad 3 for the larger. You can actually reduce that all the way to 1/9. Okay? What they want you to notice about this is that the ratios of the sides and the perimeter should be the same. So 3/5 and 3/5. 1/3 and 1/3. You guys see that? Same. Same. Okay? Then for the ratios of the area, it's going to be squared. All right? 3 squared is 9, and 5 squared is 25. Okay? Same thing with the triangle. 1 squared is still 1, and 3 squared is 9. Okay? So the first, the sides and the perimeter, same, same, squared, squared. Let's see if it's true on the next figure on the page 16. So turn over to the top of page 16. And up at the top for question number 65, now we're going to look at the trapezoid. It looks like an isosceles trapezoid. Okay? On the isosceles trapezoid, we're going to get the perimeters and the area. So the small one is going to have a perimeter of 28, and the large is going to have a perimeter of 224. That actually reduces all the way to 1/8, which is the same as the ratio of the sides. So 1/8 and 1/8. These two numbers end up being the same. Then when we find their areas, the area of the small is 27, and the area of the large one is 1,728. It's actually kind of insignificant what that area is, other than it's the squared value, okay? So this should be the same, squared. That's the main thing that they want you to notice right now. Same, squared, okay? Part D says, summarize your findings. How are the perimeters of similar figures related? So you want to say something like, the ratio of the perimeters is the same as the ratios of the corresponding sides, or the linear square, or the linear scale factor. Okay? These two should be the same. This one should be that number squared. Okay? Question number 66, we are going to skip. So just put a slash mark through it and write skip, just like that. And then finish copying down